Hello. Hello and welcome to this video. In this video, we will solve 10 more interesting problems from problem 91 to 100. And the link to download the PDF will be in description. One more thing I'll say that do not spend more than 15 minutes on a problem and look at the solution if you cannot solve the problem. If you don't want to look at the solution, then and also you cannot solve the problem in 15 minutes, you skip this problem and come back later on. So without further ado, let's get started. Question 91 says that there are two books. Let me check if it is getting recorded. Yeah, recorded. The question 91 says that there are two books, each of 3 volumes, and 2 books, each of 2 volumes. In how many ways can the 10 books be arranged on a table so that the volumes of the same books are not separated? So we treat all volumes of a book as one book, and we have 4 books because of that, which can be arranged in 4 factorial ways. However, books having 3 volumes can be arranged in 3 factorial ways among themselves, and books having 2 volumes can be arranged in 2 factorial ways. So total number of ways would be 4 factorial multiplied by 3 factorial multiplied by 3 factorial multiplied by 2 factorial and multiplied by 2 factorial. Question 92 says that a library has 5 copies of one book, 4 copies of 2 books, 6 copies of 3 books, and single copy of 8 books. In how many ways all the books can be arranged so that copies of the same book stay together? So there are together 14 books having different number of copies. Treating all copies as one book, we still have 14 books which can be arranged in 14 factorial ways. Since copies are identical, there is only one way to arrange among themselves. Therefore, total number of arranging the given books is 14 factorial. Question 93 says that in a dinner party, there is a missing boy. There are 10 Indians, 5 Americans, and 5 Britishers. In how many ways they can be seated if all persons of the same nationality always sit together? So we treat people of, they should be same nationality as one person. We have 3 persons which can be arranged in 3 factorial ways. Now 10 Indians can be arranged in 10 factorial ways among themselves. 5 Americans can be arranged in 5 factorial ways, and 5 Britishers, they should be Britishers, can be arranged in 5 factorial ways as well. The total number of seating them is 3 factorial multiplied by 10 factorial multiplied by 5 factorial multiplied by 5 factorial. So in a class, there are 4 girls and 6 boys. In how many ways can they be seated in a row so that they should be in a row so that no 2 girls sit all together? The pattern would be first we seat the boy, 6 boys, which will make 7 positions. So 6 boys can be arranged in 6 factorial ways, and girls can be arranged in 74, that is 7 factorial by 3 factorial ways. The total number is 6 factorial multiplied by 7 factorial over 3 factorial. This should be factorial. 95 says that so that the number of ways in which n books can be arranged on a shelf so that 2 particular books shall not be together is n minus 2 multiplied by n minus 1 factorial. So n books can be arranged in n factorial ways. Now we treat the 2 books as one book. We have n minus 1 book which can be arranged in n minus 1 factorial ways. But the 2 books can be arranged in 2 ways among themselves, making total number of arrangements 2 multiplied by n minus 1 factorial. The total number of arrangements when 2 books are not together is n factorial minus 2 multiplied by n minus 1 factorial, which is equal to n minus 2 into n minus 1 factorial. Question 96 says that you are given 6 balls of different colors. In how many ways can you arrange them so that black and white balls may never come together? This question is exactly like 95. So we substitute n is equal to 6. So we have got 4 multiplied by 5 factorial, that is 480. 97 says that 6 papers are set in an examination, 2 of them in mathematics. In how many different orders can the papers be given if 2 mathematics papers are non-successive? This is also like 96 and 95. We substitute n is equal to 6 and the answer would be 480. Question 98 says that in how many different ways can 15 ISC and 12 BSc students be arranged in a line so that no 2 BSc students occupy the consecutive positions? So we first see the 15 ISC student, which gives us 16 open positions for BSc students, which can be seated in 16p 12 factorial, 16p 12 ways. So the total number of ways the student of seating the student is 15 factorial multiplied by 16p 12. Question 99 says that in how many ways can 18 white and 19 black balls be arranged in a line so that no 2 white balls may be together? It is given that balls of the same color are identical. So first we arrange the black balls, which gives us 20 positions between them and on the edges for white balls. Since the balls are identical, we can choose 18 positions out of 20 for white balls, which will give us 20C18, that is 190 ways. Question 100 says that show that the number of ways in which p positive and n negative integer signs may be placed in a row so that no 2 negative signs may be together is p plus 1 c n. So we have p positive signs, which will give us p plus 1 position for negative signs between them and on the other. When signs are identical, we can choose n positions out of p plus 1 and p plus 1 c n ways. So these are very easy problems, and I'll fix the typing mistakes. So I hope that you enjoyed and found this video useful. And do not forget to work hard. Do not wait for the video to come and go ahead and solve more problems. I'll show you how you can download Algebra and Trigonometry book. So you come to my website astrolog.org and click on the second link to download the Algebra book and third link for Trigonometry book. A fair bit of warning is that there may be a lot of typing mistakes, so you'll have to work through those typing mistakes. I will fix the typing mistakes as I find them. So again, I will see you tomorrow around at the same time with 10 more problems. That is problem number 101 to 10. And slowly the problem will become more and more difficult. So make sure that you watch the problems which are basic in nature so that you have no problem solving the difficult problems. So I'll see you in the next one. Till then, keep working hard and stay curious.